Among other things, you've learned recently about how mutation and natural selection can build complex mechanisms that serve a function. So for example, I believe we showed this example earlier about the way that the mobile bones in a snake's skull cause the fangs to flip out when a rattlesnake strikes. Other mechanisms that we see in nature are even more complicated and impressive. For example, the vertebrate eye is a remarkable piece of optical work, and there are organisms that can do incredible, breathtaking things. Given all of this, it's easy to forget a few things about evolution and about natural selection. One thing I really want you to keep in mind is that evolution is not all powerful. The organisms that it forms are not perfect. And a lot of the traits that we see in organisms today are not necessarily adaptations that were put there by natural selection. One really important thing that you need to keep in mind about evolution is that organisms that evolve are not perfect. In particular, pretty much every trait or behavior in an organism is subject to trade-offs. Adaptations have a benefit in that they help organisms survive and reproduce, but they almost always have costs too. The energy or the time or the nutrients that are spent on some particular trait or behavior could be invested in doing something else that would also increase an organism's fitness. There are also physical trade-offs that operate in the physical world. And maybe the best way to understand this is if you think of a bicycle. Remember that if you've got a 10-speed bicycle, it's got high gears and low gears. If you focus your attention on that back wheel in particular, if you bring the chain all the way up so that it's on the largest gear in back, then what happens is that when you turn the pedal once around, the back gear actually doesn't move very much. But it's very powerful, okay, because all of the force that you're putting into the pedal contributes to only turning that back gear a couple times around. So each turn of the pedal moves the large gear in back a little bit, and so you get lots of force, but slow speed. In contrast, the smallest gear, if you shift up to the highest gear on a bicycle, it's going to use the smallest gear here. Now every time you turn the pedal, that little wheel goes around many times. But you're putting very little force into each turn. So that, for example, if you try to start up a bicycle in the highest gear, you're going to have a really hard time getting going. Okay, this trade-off between speed and what's called torque, or the force that you can put into something, is inherent. It's basically it's a side effect of physics, and there's no way around it. So organisms that are built for speed, maybe it's kind of impossible for them to have lots and lots of torque at the same time. Organisms with really powerful digging front limbs, that is, they're built for torque, can't run very fast with those same legs. They can't establish speed. So what evolution by natural selection has to do is it has to constantly find sort of an optimal balance between two things that trade off against one another. Importantly, as I mentioned earlier, structures and activities cost things. They cost energy, nutrients, time, sometimes risk is an important currency for an organism. And those things are then trade off against other things an organism might be spending that energy or time or nutrients on. For this reason, you usually don't see features on an organism that use energy or nutrients or time, but don't return something to the organism. Selection favors the loss of features that don't provide benefits. For example, a lot of organisms that have evolved to live in caves have lost pigment which protects them against ultraviolet light, and they've lost the eyes, which take advantage of light in order to see. So up here, you can see a eyeless salamander. Down below, you see some eyeless cave fish. These organisms have lost these features not because of disuse, but because selection favored the loss of those things. The reason selection favored the loss of those things is so that the resources that are being put into them could be devoted to something else. So one of the other things I'd like to point out about natural selection is that it can only favor structures and behaviors that tend to pass on the genes that code for those structures and behaviors. In other words, natural selection can only favor features in an organism if they help that organism survive and reproduce. There are a few weird exceptions for this. There are actually some genetic parasites within your genome. Sometimes parts of your genome compete with other parts of your genome. But for the most part, when we look at the whole organism level, we expect to see traits that help pass on that individual's genes. For that reason, anytime we see a feature in an organism that is too complicated to have happened due to chance, but it doesn't seem to pass on that individual's genes, we're very interested in it, because that would seem as though it couldn't have been put together by natural selection. But natural selection is the only process, mutation and natural selection are the only process we know of, that can develop complex functional mechanisms. So there are a handful of these kinds of things in nature that biologists have been very interested in. So for example, some birds like the widow bird have ridiculous ornaments on them. In the case of the widow bird, if you go out on the Serengeti in western Tanzania on a nice blustery afternoon, you can sit there peaceably and watch widow birds flying helplessly sideways as the wind blows them across the savanna. It doesn't seem like that tail is much of an adaptation. Similarly, when a female honeybee stings, the sting stays in the wound. It has these little barbs that stick so deeply into your skin that it can't be removed. And when the bee tries to pull away, it actually rips the stinger and some of her innards out of her abdomen. She then dies. Well, that doesn't seem to pass on her genes either. Similarly, there's some strange behaviors, like, for example, this is a moth that pollinates a plant called the yucca. It's called the yucca moth because it has a very close relationship with the yucca. The moth will actually collect pollen from one flower in a very deliberate fashion and fly to another flower and deliberately smear that pollen all over the receptive female parts of that other flower. In fact, it has evolved these special tentacles on its face that serve only to pick up the pollen and smear it on the next receptive flower and thus help the yucca. But what's in it for the moth? All of these features that I'm talking about, all of these do not seem like the sort of things that natural selection would favor. I mentioned a little while ago that if you really understand natural selection, you will also understand how these features could be favored by selection. Charles Darwin actually understood how things like the widow's bird's tail or the self-sacrificing honeybee could have evolved, and it's because he really understood how selection works.